them one at a time. Here, let me
Cool.
hit record, and then also
Okay.
let me blow this up just a little bit before I take a snapshot of it.
Sure.
I got to get all 6 curves in there. Okay, that's pretty good.
Cool.
Okay. Now,
All right.
how are we going to figure out which is 17?
So we need to find its amplitude and then its period, right?
Yes, exactly. Those 2 things. Well,
Okay.
every curve that I'm looking at except F is a tangent curve, so is C.
Mm-hmm.
So we know that these 2 tangent expressions are going to go with C and F. We'll get around to figuring out which is which.
Mm-hmm.
But we know that 17, 18, 19, and 21 are all going to be A, B, D, or E.
Yep.
All of them have an amplitude of 2, notice.
Mm-hmm.
In other words, they all go up to +2 and they all go down to -2. That one does,
Okay.
that one does, 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 and that one does. So we can't use the 2 to figure it out. We've got to figure out the period.
Mm-hmm.
Well, 17, B is 1/2, right?
Right.
Here's what you need. B is equal to 2 pi over the period.
Mm-hmm.
Well, that means the period is equal to 2 pi over B. Well, B in this case, and for 17, B is 1/2. So we need a period of 4 pi. Well, what's the period of A? Peak
I'm not sure I'm catching on.
Peak to peak. In other words, what's the difference on the x-axis from that peak to that peak? Because that's one period.
Oh, 2 pi.
What's that right there?
That's just pi. So
what the period is then is pi. Therefore, that's not our answer for 17.
Okay.
Okay. Let's look at B. What's the period that we're looking at on B?
For B, we're looking at
can't go peak to peak because we only got one period drawn. So we got to go from that point there to where it starts over again at that point. What's that period?
I'm not sure.
Well, if that's pi and that's 3 pi, what do you think that is?
Like 4 or 5 pi, or 5 pi.
4 pi.
Or 4 pi.
Every 2 units is a pi.
Oh, okay.
That's 2 grid marks for 1 pi. There's 2 pi. There's 3 pi. There's 4 pi. That's what we're looking for.
Okay.
Our B of 1/2 indicated that we needed a period of 4 pi, and that's what we got. We got an amplitude of 2 and a period of 4 pi. So B goes with 17. Okay.
Gotcha.
Just label that. And in fact, let me erase all the ink and now put that B back. Now let's look at 18.
Mm-hmm. 2 cosine of 1/2 x.
So what's the period?
So 2 cosine 1/2 x, so that would be, would that be 2 over,
what was the period on the last problem when I had B as 1/2?
It was 2 over 1/2. Or yeah, 2 pi over 1/2.
1/2, which was 4 pi. Well, it's the same thing. That period means it's 4 pi.
Okay.
That B of 1/2. Because we still got the period is always 2 pi over B. B is still 1/2. So we're still looking for a period of 4 pi, an amplitude of 2, but this time it's a cosine curve, not a sine curve.
Gotcha.
Well, this is,
so that would have to be,
that's a cosine curve, but it's not a period of 4 pi. That's not a cosine curve. This is a cosine curve, and it has a period of 4 pi. So E goes with 18. So B and E. B and E.
Okay.
Now let's do 19. What's our period going to be on 19?
So 19 2 sine of 2x. So the period would have to be 2 pi over b, just b.
What's B?
2.
Our period is pi.
Okay, cool.
Which of these is a sine function with a period of pi? And they all have amplitudes of 2. So we might as well throw that out the window as a determining factor. Is it D or is it A?
D, right?
D. For one thing, D is a sine curve. Starts in the middle, goes up. So D does exactly what sine curve does, and it's got a period of pi. If you go from the starting to the next start of the next period, you got pi. So D goes with 19.
Cool.
And that means 21 has to go with A. That's doing the work.
Exactly.
Now, the only one left is the tangent. We can do that real quick. So all we have to do is solve one of them, and we'll know what the other one is. So we've got a tan of 1/2. Let's take this one first. For tangents, the period is not 2 pi over b, it's pi over b. That's the difference. Sine and cosine, the period is always 2 pi over b. But tangent is just 1 pi over b. Notice that tangent repeats itself every pi. Not every 2 pi, but every pi. It repeats itself. Okay? So, we've got one of these tangent curves that has a period of pi over 2, C, and one of them that has a period of 2 pi, F. Well, which one do we want? Let's figure out 20. B is 1/2. So what's the period on 20?
So 20 would have to be, or the period of 20. So there would be 2 pi over,
no, it's
or
pi
1/2. Yeah, pi.
Pi over 1/2, which is 2 pi. So 20 needs a period of 2 pi. Well, which one has a period of 2 pi, C or F?
2 pi. C. Yeah, it'd have to be F then.
Correct.
For 20.
The other tangent function has to be C.
Have to be C.
And notice that in the other tangent function, B is 2. So the period is pi over 2, and it is. The distance between minus pi over 4 and pi over 4 is pi over 2.
Okay.
Cool. So that's how we do all of them. It may have been cheating a little bit to solve 3 of them and know the 4th.
It's all good.
But you saw enough work to know how we would do all 6 of them if we had to.
Cool.
So that's everything on that page, or is there stuff above it that we need to do?
Yep, no, that's it on that page. So now it's 23 through 33.
Is that the middle one, maybe?
I believe so. Or no, was that the third one?
Yeah, it is the middle.
Okay, yeah, cool.
I just got to make sure I don't close out that X. Because if I do, I close out my whole Gmail program.
Oh, you're good. Yeah.
No, I've done it many, many times. I finally learned.
Yeah.
If I haven't downloaded the file and I'm just viewing it, I cannot hit that X. It closes
Just
out.
completely X's out.
Completely reopen it. Yeah. So 23 through what?
23 through 33.
Okay. This is a lot more complicated trig than you've ever done.
It's a lot more.
I'm
Yeah.
surprised they're doing it in Algebra 2.
I am too.
This is your buddy is doing this exact stuff.
Really? Yeah, he's in Algebra 3, I think.
Well, he's in Algebra 3 Trig.
Oh, okay.
Is the name of his course, and they do quite a bit of trig. But the hardest part of trig really is these sinusoid functions, is figuring out how to graph a function and figuring out how to come up with the function when given the graph. Okay? And so I've been doing this exact type stuff with him. So I'm a little surprised to see it.
Yeah, this is...
You. But this is good. I'm glad you sent me this because I got Cole next at 8:30. And
oh, cool.
I think he's taking the same stuff. So
he's doing the same thing, yeah.
It'll be the same pages. So thank you for sending. He thanks you for sending it to me.
Exactly.
So he won't have to.
Exactly.
Find the amplitude and the period of the graph. Okay. Here's how you find the amplitude.
Okay.
Let me write this. When you are looking at a graph and you're trying to come up with its function, you want to solve for A, for B, for C, and for D. But before I say that, have they given you the full sinusoid? In other words, have they given you this as the standard?
Nope. They haven't given us that.
So the only thing they've taught you about is amplitude and period. In other words, they're not handling any phase shifts or vertical shifts yet.
No.
So the nature of our functions is going to be this. Or cosine, right? In other words, each of these three curves we would expect to describe by A and B. And I might use a sine function. Certainly 23 is going to be a sine function. 24 is a sine function. But notice 25 is a cosine function.
Right.
I'm going to use cosine when I get to 25. Okay, A is the maximum minus the minimum divided by 2. It's always the easiest way to do it.
Okay.
So in 23, what is A? There's the maximum at 1.
And then
there's the minimum at minus 1. When I say maximum and minimum, I mean that point and that point. What's the y value of it?
Right.
So take the maximum, subtract the minimum, divide by 2. What do you get?
Say you get 1 minus 1 is 0 divided by 2.
Be careful, don't drop a negative sign.
Did I drop a negative?
Yes, you did. It's 1.
Oh, okay. 1 minus a minus 1. So 2 divided by 2, which is 0.
Right.
Or 1.
Which is 1. Yeah. Right. So A is 1.
Okay.
Okay. And that's the way you get A on everything. Is you take the maximum, subtract the minimum, and divide by 2. It's that simple. So A is 1. The only other thing we need is B. What do we know B is?
B is minus 1.
Well, what's the formula for B? B has to do with the period. You can't figure out B until you figure out the period.
Isn't it 2 pi over B?
It's 2 pi over the period.
Oh, period, okay.
In other words, both of these statements are true. The period is 2 pi over B, and B is 2 pi over the period. Notice that algebraically, those are the same thing. It's just which you're solving for. Since we're solving for B, I'm going to use this one because I can figure out the period by looking at the curve. I'm not going to use the second one because I'm going to figure out the period and substitute it in for that equation. Well, what's the period?
So the period would have to be
1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi.
It have to be 6 pi then, yeah.
That's what it is.
Okay.
So I'm going to write 6 pi. I'm going to cross that out, write 6 pi. So what's B?
So that's 6 pi, so that 1/3 pi.
Not 1/3 pi. Pi's cancel.
Oh, the pi's cancel, so just
So
1/3.
2 over 6 or 1/3.
Okay.
So this equation would be y equals, don't need to write the 1. It is a sine curve. I do need to write 1/3 x. So that's that one. Now, what's A? I'm going to erase all this stuff over here so I have more room to write. What's A on the second one?
For 24.
Uh-huh. Yeah.
So, okay, no, you're good. So A would have to be 1 again.
Matt, what's the maximum?
0.5. And then the minimum's minus 0.5.
Okay.
So that would be 2. So
hold on. 0.5 minus a minus 0.5. That's like adding.
Just 1, I meant.
So that's 1, but I got to divide by 2. So A.
So just 1/2.
Always remember the maximum minus the minimum divided by 2. And that's going to be crucial because when you do get the vertical shift, which is D, as in David,
Yep.
then it's the maximum plus the minimum divided by 2. So A and D become really easy to solve for. One is the maximum minus the minimum divided by 2. The other one's the maximum plus the minimum divided by 2.
Okay.
Okay? Just get you a little ahead of the game, even though you probably won't get that part of sinusoids until next year.
Probably not, yeah.
I got to solve for B also. No, actually I don't. It just wants the period. Okay. I don't need B. Just tell me what the period of 24 is.
So, okay. So the period of this would have to be, so it would be 2 pi over B.
No.
No.
We don't, first of all, we don't know what B is.
Okay.
Second of all, they don't really want it. They didn't want the equation, so let me erase that, because they didn't really want that. They wanted the amplitude and the period. We gave it to them. The amplitude was 1, the period was 6 pi. So A, here, I'll answer the question. A was 1.
So the period just has to be 2 then.
As measured from the curve is 6 pi. I don't care what B is.
Right.
They're not asking
for 24 it has.
So on 24, A is 1/2.
And then
period?
The period would be 2.
Yeah. Just read it off the graph. Go from there to there. Now, we're not used to periods being numbers. Most periods have a pi involved, right?
Right.
But the fact is that pi is a number, 3.14. So it's okay to have the x-axis in numbers and not in terms of pi. 23, the x-axis was in terms of pi, and that's more typical. But 24, the x-axis is numbers, and that's perfectly fine.
Okay.
Okay. 25, what's A?
So A would have to be maximum, which is 2 and or 3. And maximum is 3 and then.
Hold on. Read the grid. If that's minus 2, that means each grid mark is 2 units. So that's minus 4.
And then 4.
That's plus 4.
So okay, so it'd be 4 for the amplitude.
Okay, so the amplitude is 8 divided by 2. What's the period?
And then the period, I can't quite read that. What does that say?
That's pi
Pi?
over 2. That's half of a period.
And then pi, so pi over 4.
No, the period is pi. In other words, the period is the distance from there to there. Peak,
right.
peak to peak. And
Peak
that number right there is pi.
Gotcha.
So the period is pi on 25.
Cool.
All right. What's next?
26.
Okay. Instructions are the same. What's the amplitude?
So the amplitude would be 1/2.
Okay. What's the period?
Pi.
No.
Right.
Period is 2 pi over b. This time we know what b is.
Oh, so 2 pi over 1/2.
No. That 1/2 is a. What's b? What's b in 26? B is always the coefficient. Yeah, it's the coefficient of x.
Right.
So b is pi.
Gotcha.
So the period
is just 2.
Yeah.
Okay.
So
cool.
Period of 2, I'll just write.
Cool.
That's covering up the problem. That doesn't help. But
you're good.
You know what it is. Okay. Here, what's the amplitude on 27?
Hold on. Okay. So for 27, so amplitude is 1.
What's the period?
Then the period would be 2 pi over 2. So the 2's cancel out, so it'd just be pi.
Good. 28, what's the amplitude?
Okay, hold on. Let me write. Sorry.
You got the pattern down now.
Yep. So for 28, the amplitude would be 3.
What's the period?
And then it would be 2 pi over 1/4 for the period.
No, that's not an answer. You simplify that.
2 pi over 1/4.
2 divided by 1/4. How do you divide by a fraction?
Multiply by the reciprocal.
Okay, what's that equal to?
So that'd be times 4. So 8 pi over 1.
8 pi. That's the period. 29. Amplitude?
So 29, the amplitude. Let me write this down. Okay. So for 29, the amplitude would be 5.
Period?
And then the period would be 2 pi over 1/2, which reduces to 4 pi.
Okay. Number 30. Amplitude?
Okay. Sorry, I just gotta write it down real fast.
Well, you're so good at these that I don't think you need to write it down. I think you're getting it, and you should retain it.
I'm getting it, yeah. So the amplitude would be 2.
Every one of them right, so.
And then so the amplitude is 2, and then the period is 4 pi.
Oh, not quite. What's b on 30? Tell me what b is.
2 pi over 1/2.
No.
Oh, 1/2 pi over 1/2 pi.
1/2 pi, or pi over 2. So now tell me what the period is. Because we know the period is 2 pi over b.
Right. So the pi's would cancel out.
Well,
actually, no, so you'd multiply it by 2 over pi.
Don't get confused here. We got 2 pi over b, which is pi over 2. So you're right. Flip and multiply. The pi's cancel out, and you get 4.
Now 4 pi.
The period is 4 on, what one was that?
That was 30. That was 30.
30, right. Okay. Here, let me erase all of this so I got room to write.
You're good. Okay. Yeah, so for 31, the amplitude is 1/3. And then the period, so it would be 2 pi over 4 pi, which is, pi's cancel out, so it's 1/2.
Good. Draw one cycle of the function's graph. Well, first of all, it's 8:29, so we got to go.
Sure, yeah, no worries.
Second of all, this is one of the few things I've ever encountered where I can't do it as easily online as in person. In other words,
That's all right.
if we were in person, I'd have you pull out a piece of paper and graph that sucker.
Mm-hmm.
I can't do that online. I can graph it, and I can ask you to tell me how to graph it, but that's as good as I can do. Well, I kind of discovered this working with Justin Allen.
Oh, okay.
And that I haven't done him online yet. Everything we've done has been in person at his house.
Oh, really?
And
okay.
Yeah, and when we got to this section where he was supposed to graph stuff, I realized, wow, I can't do that online. I could if you had a drawing tablet, any drawing tablet. In other words, that's all you would need is like the thing I've got at my computer, because I have the ability to switch presenters, so I could make you the presenter and then you could graph this stuff for me.
Okay.
Anyway, how'd your baseball go this weekend?
Oh, it was rough. We played Ralston Valley. We lost. But I got in the last inning and turned a double play, so that was good.
Okay.
Always
a silver lining, huh?
Exactly. So we play Dakota tomorrow. So that's a big game because that decides whether we get home field advantage in the playoffs or not.
Oh, okay.
So if we win that, we get home field advantage, which is cool.
A big game. Well, good luck.
So that'll be good. Yeah. Definitely. Mr. Yansak is one of their head coaches there. So.
You're kidding.
That'd be kind of cool to.
Coach where? Dakota?
At Dakota, yeah. He got fired at Chatfield, so he went to Dakota.
Oh, I thought you were going to tell me he's teaching at Chatfield and coaching at Dakota. I was surprised at that. He got fired at Chatfield.
He did get fired.
Complaints that he got fired. I'll be darned.
From the coaching job, not teaching.
Oh, he's still teaching.
Yeah, no, he's still teaching at Chatfield.
He's coaching at Dakota. Got fired as a coach, so he's coaching at Dakota Ridge. Okay, well that's kind of what I thought you meant in the first place, but.
Good. Yes, that'll be kind of cool.
Yeah.
I want to really show him what we got because he was not one of my favorite teachers.
Yeah, really. That'll give you extra motivation, huh?
Oh, exactly. That'd be real cool.
Might even try some line drives into the dugout.
Exactly. Yeah. Just purposely hit it into there, but I'll accidentally overthrow one to third and see if they can react to it.
All right, Dylan. I got to run. Awesome. I'll see you Wednesday night.
Sounds good. Thanks for coming.
Bye-bye.
Okay.